Okay, so we are working on synthetic division, and one of the things with synthetic division that's kind of interesting is this is one of the few things in Algebra 2 that you did not do at all in Algebra 1. A lot of the stuff that we do in Algebra 2 that you didn't do in Algebra 1, you didn't really do in Algebra 1, but you kind of like, you got close to it. Kind of like with factoring the sum and difference of cubes. Yeah, you didn't do that in Algebra 1, but we did factoring, we did some of that other stuff. Synthetic division, you did not even come close to any of this in Algebra 1, so this is completely new, so make sure you're paying attention to this. The other thing I'll say before we start is there's two types of division. There's synthetic division and long division. Long division is really interesting. Some of you guys would really like it because it's kind of like a lot of pattern stuff. I like it because it's the same long division you guys learned back in like second or third grade. It's just with polynomials, so it's the same steps. You just kind of have to look at it a little bit differently. However, long division is more difficult. So the positives and negatives. Long division is more difficult, but it works for every single polynomial. Any polynomial divided by any other polynomial, you can use long division. It works for everything. Synthetic division is easier and quicker, but you can only use it when you're dividing by a binomial. You can only use it when you're dividing by a binomial. However, for our reasons, we're just going to do synthetic division, so you won't have to worry about any of them that you can't divide. So that's my little intro. The other thing with this is I tried to figure out what the best way is to kind of intro this and try to do it kind of like my step. So this one's a little bit different where the first couple problems we do are kind of going to be really super random, and then you'll kind of learn where we're putting this stuff in. So what I've said with synthetic division is that it's not really, the math isn't really that difficult. The thing that people miss a lot is that it's very particular on where you're putting your numbers and how you're setting it up. Once you have it set up, again, not saying that it's super easy, but the math isn't the hardest part. I would also like to give you like a step-by-step way to do this, like I do with most of my other things. But synthetic division is one of those things that honestly maybe is better just to show you how to do a problem and then do a second problem and a third problem. By the fourth problem, you kind of pretty much know those steps. So we will set this up later. I'll show you how to find this number that's in the box and how to find all these numbers. But we always start with synthetic division. We have this box. We have a vertical line over here that separates our last number with the second to last number. Then you have this horizontal line, and we have a space right here. We're going to add some numbers in here. So again, the math behind this is really just multiplication and addition over and over and over again. You have a calculator, so you can use that for your help. And it's just knowing the pattern. The pattern, without further ado, that number one you drop straight down. Your first number you drop straight down and go to addition. To get the number under the 7 we're eventually going to add, you take your number in the box and you multiply it by that first number. So 5 times 1 is 5. It goes under your 7. You add those together. Negative is negative 2. But now you just keep doing that loop. You keep doing that loop over and over. So I took 5 times 1 to get this. Add those together to negative 2. So now I take 5 times negative 2 to get negative 10. It goes under my 4. Or sorry, my 14. 14 minus 10. Technically, it's 14 plus negative 10, but that's the same thing as 14 minus 10. It's 4. And keep repeating that process. 5 times 4 is 20. 10 plus 20 is 9. Use a calculator if you're not sure. 5 times 9 is 45. Negative 45 plus 45 is 0. Now, most of the problems we do today will have a 0 like that. Technically, there are some problems we'll talk about down here where you will have a remainder. I think you can look on the practice test, but I think on the test there's maybe one that has a remainder that you have to deal with a little bit. But if else fails, don't worry about remainders because, again, there's maybe one on the test like that. But most of the problems we do will not have a remainder there. It'll just be a 0. And again, I'll talk to you about how to get that and what we're doing with that a little bit later. Now, once we're done with this 1, negative 2, 4, 9, that's what we're going to be using to get another polynomial. We'll talk about that later. But I want to get this basics. If I can get you to understand this basic part, then the rest is just setting it up. The next one we have is significantly longer. I put it on here because, again, by the time you're done with this one, I at least hope you understand that pattern. That said, a lot of people, is the very first step is dropping that 9 down. Don't do anything with that 9, you just drop it straight down. Then, now you start your process. -2 times 9 is -18. -18 is -30. -2 times -30 is +60. Again, be careful with your positives and negatives here. -60, 3 plus 60 is -3. -2 times -3 is +6. Just making sure that's right. This is the same thing. I've done this 3 times, and every time it doesn't seem like I'm doing it right. We'll see. 93 plus 6 is 99. 2 is -198. Sorry, can't read that. Is -132. -2 plus 2 is 45. Again, you just keep doing this loop over and over again. -2 times 45 is -90. Whoops. 24 plus -90 is -66. -6 is 132. Plus 132 is 24. And -2 times 24 is -48, which ends up giving us a remainder of 0, which again, we'll talk about that later, but that's always a comforting feeling. And sometimes you will have a remainder, I get that. And let's just say if you look at your practice test, I think you'll know which one you get a remainder on. I want to say it's like, maybe even says what is the remainder of this one. But for the most part, we get 0. So if you get that 0, that's usually a pretty good confirmation you did things correctly. Any questions before we move on? Now, again, it does get difficult or more difficult than that in the fact that we have to set that up. And once we get our answer, there's still some problems we have to do from there. We still have to do some factoring. We still have to do some solving with our answers. But that's the new stuff for today. Okay. So the next thing is it will tell you a lot of times where it'll say, what are all the factors given the 0? Given this first 0. Don't make this harder than it is. X minus 5, the 0 is, if you set it equal to 0, 0 is 5. I don't want you to look at it necessarily as this is a -5, so your answer is a +5. Because occasionally if you get one that does have a leading coefficient like number 5, that can kind of confuse some students. But the fact of the matter, that's what it is. X minus 5 equals 0. So we solve that, you get x is 5 is your 0. Okay, hopefully not too bad. X plus 6, your 0 is -6. And just so we're clear, just to give you a little glimpse into the future, the 0 that we're finding is the number that we're going to end up putting in the boxes like we had up here. So we'll get back to that in a second. Now, they also might give you one like this one, number 3, this equals 4. Guess what? That's your 0. We can't solve that. It's already solved. That's the 0 you're using. And number 4, x equal -7. Again, same thing. That's the 0 you're using. But be careful. We won't have a lot of them like this, but 3x plus 2, don't just say -2. If you can do this one in your head, by all means, that's your prerogative. I am always nervous to. Usually when I'm making an answer key, I do it in my head, and then I still go back and check it because I'm just not super confident. But for this one, since there's a 3 in front, sometimes it does help some people to go ahead and solve this. Doesn't take too long. But for this one, the 0 is -2 over 3. I've also seen people that try to do this in their head and they have to think so hard about it that by the time they finally get the answer without doing any work, I could have just done the answer by doing all the work. So it's up to you. Any questions on finding those zeros? Okay, so the first thing we're going to do then with synthetic division, we're not doing any of the factorings yet. We're just doing the dividing step so far. We're just doing this dividing part. And I set this up where you can kind of see every kind of way to really ask you these questions. So the first one, they'll give you a division problem. So x to the fourth minus 7x to the third plus 2x squared plus 45x minus 20 divided by x minus 4. Well, the first thing you need is, well, if x minus 4 is the binomial, then x is equal to positive 4, just like we got done doing. Synthetic division, that is the number that goes in the little box. I just saw somebody's notes one time that called it the house. I don't know if there's actually a mathematical terminology for that, but that's where it goes. The other numbers we have are all the coefficients from our list. Now, one thing I can tell you is a glimpse into the future when we do 3 and 4, you have to have every exponent. So when they start with a 4, you need every exponent longer than that. So I have an exponent of 4, 3, 2, 1, 0. So we're good to go. If we ever don't have that, like down here we have a 3, we don't have a 2, we're going to need to put a 0 on that for kind of a placeholder. We'll talk about that once we get there. So once you have 4, 3, 2, 1, 0, just put all your leading numbers. Do not put the x's with them. So my leading number is 1, negative 7, 2, 45, and negative 20. Your lines go between your 45 and your negative 20. That's how you set up synthetic division. Like I said, once you have it set up, we just did on those other two. If you're a step ahead, you might be solving this already, but if you're not, that is fine. One straight down, one is 4. Negative 4 is negative 3. 4 times negative 3 is negative 12. 2 plus negative 12 is negative 10. 4 times negative 10 is negative 8. 45 minus 40 is 5. 5 times 4 is 8. Negative 20 plus 20 is 0. So again, we're on track for this one. Last but not least, those numbers you got, actually, remember these numbers I told you, the 1, negative 7, 2, 45, that's all leading numbers, all the coefficients to these. Same thing with your answer. These numbers are all coefficients to different variables. So the way we always start, this 0 over here, we kind of forget about that for now. So we start with the constant, with one that does not have an x at all. So you don't have to do it this way, but I think it's beneficial to do this little extra step. I go ahead and I put down by the 5, I put a c for constant, and then the 10, I put an x, then an x squared, then an x to the third. One reason I do that is because I have done this when I was in high school. By the time I'm done, I realize I have to go back and do exponents because I with x to the third. So your answer then for this one is 1x to the third minus 3x squared minus 10x plus 5. Again, later on what we'll do, that answer, we'll do some more factoring or some solving to get our answer kind of break down even further. You know how to do factoring. That's not the end of the world. Yes.
So we just like subtract from the first exponent, which is 1 less the first time.
Yeah. So I always just do it this way, where I just label the constant x squared, x to the third, so don't worry about that. You're right. And one thing, not to go into I'm not going to go into a lot of depth on this, but if we started with an x to the fourth, But then we're dividing everything, we're taking out an x. That means we're only going to have one x left there because we took out an x. Same thing, if you divide this one by something, we end up with an x squared as our leading coefficient because when you divide by x, you're taking an x out of it. Don't really need to know that, but fun fact for the day. The more you know. Now, again, if you're looking at that and you're like, whoa, that's super weird and confusing, you're absolutely right. I totally get it. What we're done with today, we're going to do that type of problem. I mean, we do every single one of these problems. So what is there, like 15? So we'll probably do it on about 15 times. Probably a little less than that. I'll probably skip a little bit. By the time we're done, it's going to be, hopefully, if you guys actually pay attention, participate, it's going to be pretty much muscle memory. So number 2, it says, it gives you the function, says where x is equal to -1. So they give you the 0 for this one. And that's one of the things a lot of students struggle with. How do I know when I have to solve? And how do I know when I just use the one they gave you? Well, it's because they gave you x is equal to. There's no x is equal to, so you have to find it. They give you x is equal to something. That's the one you're using. So that is. Then my leading numbers, I have 1, +2, -1, and -2. Then you put your little lines, make your boxes. My 1 drops straight down. -1 times 1 is 1. Add those together. -1 times 1 is -1. Add those together. You get -2. -1 times -2 is +2, which is 0. Now, again, technically, your first number is going to be an x squared because we started with x to the third. But again, you don't really need to know that. I just know this is my constant. So that's my x squared. So your answer is x squared plus x minus 2. Now that looks a lot more like what we're going to do later, where then we'll factor out those problems. But that'll be later today. Again, the good news is you guys know how to factor. Hopefully. Any questions on those? Before, the other tricky thing that does trip up students a little bit is a problem like number 3, because a lot of students do it the same way as before, where they say, okay, so my x is +2, so in my box I have +2. +2, put 1, -19, and 30. That's not right. Remember, every exponent needs a place. Every exponent needs a place. So I have an x to the third, so that's 1. If you don't have an x squared, you still need to put a 0 in for that, because technically it's 0x squared. And then we have -19 and 30. Now again, before you even start, you can tell if you're going to do that. I just see. So this is as an exponent of 3, so that's our starting point. So it should have 3, 2, 1, 0. On the 2, so we need that 0 part. Once you have that, now again, it's the same thing as before. Go straight down. 2 times 1 is 2. 0 plus 2 is 2. That's fine. 2 times 2 is 4. 19 plus 4 is 15. 2 times -15 is -30, which is 0. 15 is our constant. Our x is our x squared. So we end up with x squared plus 2x minus 15. Finish that. And again, if you're ever curious, you could look it up or you could ask, but long division does take longer than that. I will tell you, some of you would like long division more, but the reason you would like it more is because it does take longer. It's one of those problems that's kind of like a logic puzzle. And when you finally get all your pieces and you've used a whole sheet of paper on one problem and you get a remainder of 0, it's pretty satisfying. I assume. That never happened to me. I always got them wrong. And moving on to number 4. Now, I will tell you, number 4, I think, I'm not sure we will see. It'll be a great surprise. I'm on the edge of my seat. So, again, we need all our exponents. So I have an exponent of 3. I need an exponent of 2 and 1. And then we do have an exponent of 0, so that's good. So, first off, my 0 is -5. That's perfect. So I have my -5 in my box, and my numbers I put up here with the 2, and then we don't have an x squared, so a 0. We don't have an x, but then we do have a 251. Then, same thing as before, the 2 drops straight down. -5 times 2 is -10. 0 plus -10 is -10. -5 times -10 is +50. 0 plus 50 is 50. -5 times 50 is -250. So we do have a remainder of 1. Now, here's the deal. I only did one of these. There's a chance that, honestly, not to be that guy, but next year, there's a chance that I just won't do the remainders. I mean, they're kind of nice to know, but synthetic division is one of those things that I don't want to take too much time on it, but it almost would be worth taking 2 days just to make sure you can kind of tie together those small loose ends. But the way you deal with your remainder, I don't know if you guys remember when you had a remainder when you just did normal division before, like 3 divided by, I don't know, 52. No, 52 is maybe moved by 3. 55, say. I don't know if you remember what to do with the remainder, because I know you guys probably all remember when you did the R, so it was a remainder of 1. But once you actually learned that remainder, you did it where you just put the remainder over the original number you're dividing by. So what we do with this one is we still have our constant, our x, and our x squared. So we still have 2x squared minus 10x plus 50. I'm going to run out of room. 2x squared minus 10x plus 50. But then you're going to have plus, and you're always going to have a plus, and then don't make this harder than it is. The hard part is remembering it. Your remainder is 1, so we put that as a numerator, and your denominator, you always put the number, the binomial that you're dividing by. You do not put -5. That's, again, one of the things a lot of people miss. So you're dividing by x plus 5. It's always going to be a plus. Technically, there's where you get a minus, but I don't care about those. It's already complicated enough. I would put plus, and then 1 is the remainder, and then it's over whatever we're dividing by. Now, again, don't stress too much about that. I honestly think if you look at the practice test, there's only one question, and the question just says, like, what is the remainder? You don't have to put it in the fraction. So this one, the remainder would be 1. But it's nice to know, and again, it's not anything too difficult. It's more just, it's a difficult thing to remember. It's one extra thing to look out for. So go ahead and do number 5 and 6 on your own. I'm not going to call on people today, mainly because this lesson's a little bit long. I want to give you time to work on your practice test or your worksheet or whatever you need to do. So go ahead and do these on your own, and then I'll put the answers up here in a second. All right, I put my answers up here for you guys to look at. Make sure you check. But just FYI, with number 5, I almost missed number 5, and the reason is because I took -10 times 7, and I put +70. And so I got confused because if I add those together, it gets a really big number, and if I multiply by 10, even if you have a remainder, it's usually not like in the thousands or something crazy. So just make sure you pay really close attention to your positive and negative. That's kind of a big deal with this. Any questions on any of those? You remember those and for the exponent of 1. Okay, so again, that's the new stuff for today. Now we're going to get a little bit into more depth when now we want to use that to find the zeros or find the factors. If you have clues, some crazy things that are to the 4th power, to the 5th power, to the 6th power, or to the degree of 4, 5, 6, provided you know a couple hints and you can use synthetic division. Now, I'm not going to go into the whole reason why. Those things, if I had time, maybe I could do that, but I don't actually think it would help you guys or you'd be interested. So they want to know what are all the other zeros, or what are all the zeros, not just all the other ones. They want to know what all the zeros are to this problem number 7, but they're going to give you a hint when they're going to give you a 0 to start with. So basically, we're solving this one. So solve just like we did the quadratic formula or the factoring or even the sums and differences of cubes when we solve those. we're solving it just like normal, or we're solving it like we have before, and now we're doing a synthetic division. We're going to use a little bit of we're going to use that to kind of get it to something that we're more used to. So what is the synthetic division part? Not any different than what we've been doing today. 21, negative 21, negative 5. Make sure you have all your exponents. 2, 1, 0. So we're good. Division part. 5 down. Negative 5 times 5 is negative 25. Negative 4. Negative 5 times negative is positive 20. Add those together, get negative 1. Negative 5 times negative positive 5, which gives us 0. Now, I will say all of these will give you a remainder of 0. I don't think you can do it if I said, what are all the other zeros, and then I gave it to you, I gave you a 0 that wasn't, actually you can't. If I gave you a 0, that's the whole idea. This negative 5, it is a 0 to this, it is a solution because it gives you a remainder of 0. That's the whole idea. If I ever give you a problem like this, you'll always get 0 for your remainder. So that leaves us with x squared minus 4x minus 1 is equal to 0. Zeros of that. Now, you could use quadratic formulas. You could also factor these. And for the most part, factoring is going to be the easier way for these. So this one has a coefficient. I'm sorry, I know it's a little bit of a pain, but it's good to get some of that practice. So looking for 5 times negative 1 is negative 5. Factors of negative 5 has to be negative 4. Take a list you can. We end up getting 1 and negative 5. Those two numbers multiply to be negative 5 and add up to be negative 4. X plus 1, x minus 5. Remember, that's not your answer yet because we have a leading coefficient. We still have to divide those numbers by my coefficient, by 5. With x plus 1 over 5, and x, when you reduce it down, is negative 1. Now, here's the good news. Now, I know this is a lot of time and a lot of work because this is just something small at the end. But normally speaking, when we factor, if we have a fraction, we take that number in the bottom, we put it up with a 5 with our x, so it would be 5x plus 1. If you want to do that, you can. If it's just an else number, you can actually do that. You're not going to miss it. But we're solving for x right now. And so if you go ahead and do that, you're actually going to have to then undo that when you're solving for x. So really a little bit of a shortcut. And what would you plug into that to get 0? Well, if it's plus 1/5, you just plug in negative 1/5. Negative 1/5 plus 1/5 is 0. Same thing, the other one is 1. So they want to know what all the zeros are. Your zeros are 1, and don't forget your negative 5 that they gave you from the very beginning. One quick thing to do to double check. If you have a degree of 3, which means that 3 is your highest exponent, which is not the actual definition, but for our purposes, exponent, if you have a degree of 3, that means you have 3 zeros. So you always want to double check when you're done, make sure you have all of them. Don't forget the one they gave you. I actually have told students in the past where wherever you're going to put your answer for this, I start, before I even do any work, I start by putting x is equal to negative 5. So I have that in there so I don't forget. We're going to do more of those, obviously, but that's it. That's the hardest stuff we're doing today. I know for some of you, you're like, yeah, that doesn't surprise me. This is super hard. I apologize, but it's not going to get worse in my class. It probably will in your next class because you don't have me as a teacher, and it's just going to be super lame. At least that's what I've heard. So for this one, they give you the 0. So again, not a bad idea wherever you're going to put your answer to start with x is equal to 2. So I start with my synthetic division. We have 5, 4, negative 20, negative 16. So my 5 goes straight down. 2 times 5 is 10. Add those together. 2 times 14 is 28. Add those together. 2 times 8 is 16. Add those together, get 0. Again, with these types of problems, you have to get 0, or else 2 is not a solution. And again, I apologize. If I would have known, I would have changed this. And it's not, I mean, I shouldn't have to apologize, I guess. But I do understand that I gave you 2 of them that do have leading coefficients. Hopefully that's not the end of the world. We have 5x squared plus 14x plus 8. Now the good news is if you're factoring this one, 5 times 8 is 40. We're looking for factors of 40 that add up to be 14. Hopefully you can find them pretty quick. It's 4 and 10. So we have x plus 4, x plus 10. And remember then we are dividing both of those by 5. So we get x plus 4 over 5, x plus 2. Again, technically, if you want to put that 5 in front of your x, you can. It's just then you're solving, so then you're going to subtract 4, then divide by 5, and you're back kind of where we're at. So this gives us the 2 answers of x is equal to negative 4 over 5, and x is equal to negative 2. So those go up, hopefully, with your other answer. Negative 4 over 5, negative 2. Those are your answers for that one. And this is one that, in my opinion, I would claim the reason this is as difficult as it is, and the reason some people miss this and they're terrible at it, is because, first off, it is completely new. It's nothing with Algebra 1. But also, these problems do take a while. Again, I would claim, personally, I don't think they're that hard. It's just that they take so long that they kind of make themselves hard. All right, I'm going to erase this quick. Or not. I'm just going to write more. Give myself some room here. So if they give you a factor, so instead of giving you a 0, they give you a factor, it's literally the exact same thing. The only difference is they don't give you a 0, so you have to find your 0. So for this one, they give you minus 3. Your answer is 3. Now again, if you don't know how to tell, one of them has an equal sign in it. One of them you have to solve because it doesn't. The same. In one of these examples, we have 3. We have 1, 3, negative 13. So this is a tricky one. 1, 3, negative 13, negative 15, but we also need a 0. Remember, all the exponents needed counted for. The 4, 3, 2, 1, we still need the 0. Now, one thing you can do that's kind of a little bit cheating, but a little bit, I mean, I don't know if it will help you or not. You notice that we can factor out an x out of all this. And so technically, you can factor out an x. And then you can have x to the third and kind of do it the same way. So if you want to do it that way, you can. Division. 3 plus 3 is 6, not 9. 15. 5. 3 times 5 is 16. 0. And 3 times 0 is 0. Also gives you 0. So we end up with 1x to the third plus 6x squared plus x. That's it. And we need to solve that one. Well, the good news is, again, they all have an x in there, so we can start by factoring out a greatest common factor of x. So I have x squared plus 6x plus 5. Now all of a sudden, it's a little bit easier to manage. It's a little bit easier to manage. Factors of 5 add up to be 6. Be careful. People put 2 and 3. 2 times 3 does not equal 5. And 2 plus 3 does not equal 6. This has got to be 1 and 5. Don't forget that original x. Negative 5 for one of our answers. Negative 1 for one of our answers. What about this x that we factored out? What would you plug in to make that 0? Yeah, just 0, because it's just in there by itself. So we also get x is equal to 0. So your answer for this one is a little bit longer. There's 4 of them. We have 3, 0, negative 1, negative 5. Those are all your answers. And again, Makes sense because we started with an exponent of 4, so we need 4 zeros for that. We need 4 answers. So go ahead and do number 10 and 11 on your own. Same thing. I'll let you guys work on this a little bit, then I'll put the answers. And then we'll talk about, I'm not going to do the other you do section, but I will probably do 1 or 2 of these next ones with 12 and 13. All right. Any questions over those two? Now, the difference with the next ones we're going to do is we have a fraction. Now, originally, I thought that if you have a fraction, it's not really that much different because you guys get to use your calculators, and your calculators are super advanced now where you can put a fraction in there really nicely. So don't make this harder than it is, but there's one important discovery I made the other day, and I don't know, I was not able to like do enough. I wasn't able / was too lazy to do like 100 examples to see if it worked a lot, which definitely is not a way to prove if something actually exists. But I don't know if this works a lot or if it doesn't, but I wanted to say this halfway through. So first off, we have to find our 0. So if you need to solve this for 0, you subtract 1 by 5, so you get x is equal to -1/5. So -1/5 is what we have for our fraction. Make sure I have enough room. 5, 21, -21, and -5. 5 straight down. Now here we have -1/5 times 5. When I was in high school, this would have probably made me cry. I was a little bit of a crier, and I was not good at fractions. That combination definitely brought tears for sure. So if you need to type in -1/5 multiplied by 5, it'll just get you -1. 21 is positive 20 multiplied by -1. -1/5 would be -4. -1/5 times -25 is positive 5, which gives you a remainder of 0. Here is the part that I have discovered, and again, I'm not even going to tell you that it works out most of the time like this, but it seems like every problem I did, it did work out like this, but again, I only did about 3 or 4 problems. So if you put your answer then, or you put your polynomial, this is your constant, your x, and your x squared. 5x squared plus 20x minus 25. Before you factor that, and again, I don't know if it works like this every time. Definitely double check this, because one of your practice tests was the same thing, and every time I changed it, didn't work at all. Greatest common factor from this part. I did not want to do that because I did not want to add 1 extra thing to your plate, but I don't know if it's avoidable or not. But you can take out the greatest common factor from here. So before you factor this, take out 5 from this one. Now, I know the hard part about that is just realizing it's there, because once you take the 5 out, it actually makes it way easier. X squared plus 4x minus 5. And since we didn't factor out an x, before when we factored out an x, one of your answers was a 0. If we factor out a 5, that's not anything. You sum in to x to get 0 for that 5, well, nothing, there is no x. So once you have that 5 out there, we can forget about it, just factor what's inside these parentheses. So factors of -5 add up to be 4 are going to be x plus 5 times x minus 1, I think. So we end up getting x is equal to positive 1, but don't forget, we also get x is equal to -1/5. That's what we were working with at the very beginning. I will say this to make sure we're all on the same page here. It maybe doesn't work like this every time. So don't take out a liar if this happens and doesn't work like this. But if you ever have a fraction that you're doing synthetic division with, it seems like every time you have a fraction, that's when you have this where you can factor something out of your quadratic when you're done. Where you take out the greatest common factor and then you can factor the rest. I could be wrong, it might be different. But that's what I found, again, on the 3 or 4 that I did, which is not a mathematical proof. I don't need you going to geometry when they talk about proofs and be like, well, Mr. Steffen said, No, you can't just do 100 examples and say it works all the time. But for our purposes, you can do 100 examples and say it works most of the time. So maybe it does work. My biggest thing is I want to tell you, if you ever have a fraction when you're doing synthetic division, that's when it seems like you're going to be able to do the quadratic, to take out a greatest common factor before you factor the quadratic any further. And that's this step over here. I'm going to do one more of these. I'm going to do it fairly quickly because I want to give you guys time. You guys have a little bit over 30 minutes, so I want to give you a little bit of time to work on your practice test. But we'll do this one, and we'll see what that looks like. So I give you your x is -3/5. Change color so we don't get confused. So we have 25, 150, 131, and 30. Definitely be ready to use your calculator for this one because this fraction is from the last one because you have 3/5 instead of 1/5. So drop your 25 straight down. -3/5 times 25 is 15, question mark. $150 minus 15, 135. 135 times -3/5. If you can do that in your head, by all means, go ahead and do it, but I would not risk it. It's -81. Add those together. 50 and -3/5 times 50 is -30. So that gives you 0. So again, we end up with 25x squared plus 135x plus 50. Now, I'm not saying you can factor out 25 from everything, but you can at least factor out a 5 from all those. I factor out a 5. I'm going to squish it down here. We get 5x squared. 135 divided by 5 is 27 plus 10. So now you're looking for factors of 50 that add up to be 27. Factors of 50 that add up to be 27 are 25 and 2. So x plus 25, x plus 2, sorry, running out of room. Then again, don't forget we're dividing both of those by 5. So we end up getting x plus 5 and x plus 2/5. So your answer, x is equal to -5 from this one, -2/5 from this fraction, and don't forget your -3/5 from the very beginning. So again, it's not super lovely after you factor out that 5 on this one, but it still is a lot easier than trying to find 25 times 50 is 1,250. So factors 1,250 to add to 135 is going to be a little bit more difficult. Oh yes, I forgot about that. Yeah. This one's very X in there. You're absolutely correct. Assuming you had a teacher that didn't do that and double check things before you printed them off, that would be your answer. Let's just always try to work on under the assumption you have a good teacher. Is the problem. Thank you for pointing that out. Honestly, I'm glad that was a mistake because I thought it was probably going to be like, from the very beginning, I put 25 instead of 24 and all of it's wrong. It's the story of my life. All right, if you guys don't want to do 14 and 15, that's fine. I'm not going to do answers up here if you want. You do not have to do them. If you want to go ahead and start working on your practice test, that's fine. Remember, you do not have an exit ticket for this section. Your practice test to look like these. All right, real quick, again, I know a lot of you guys didn't do these two, but these are the answers to 14 and 15 in case you did, or in case you want to look back or later watch the video on this. Again, one thing, same thing I said before, and again, this does not mean it happens all the time. I want to make sure if there's one thing in math I want to teach you, it's that you can't just say, oh, this happens all the time, so it works. But We've done 4 of these now together, and every single one of them, if you have a fraction that you're dividing by, you can factor out something. This one, at the end, we're able to factor out 3. The other one at the end, we're able to factor out 5. I don't know why that is. If I sat down and really thought about it, I probably still wouldn't be able to figure it out, but I could try. But it just seems like all the ones I've done, if you ever use a fraction up there, you have to take out a greatest common factor before when you're dealing with your quadratic. So once you get to this step with the quadratic, once you get to this step with your quadratic, you have to take out that greatest common factor. So again, if it's not like that, I'm not saying you're wrong, but on the test or the quiz, I would definitely look out for that.